Good morning, guys. This is a new week, and your progress report grades have been updated. So make sure you are checking Infinite Campus so that you know what your grade is, and make sure that you check that you have no missing assignments. This week, I have a new quote for you. It had been a while since I changed that. I really like this one. The future belongs to the curious, the ones who are not afraid to try it, explore it, poke it, question it, and turn it inside out. And we have a new critter of the week as well. Our critter of the week is not just any whale, but the blue whale, the deep sea buffet. And I have a little video. So guys, what this is this is a dead whale on the bottom of the sea floor, and these are all of the organisms that are now making a feast of that. So we've been talking about trophic levels and how decomposers, if we're not in an aquatic environment like a forest environment, decomposers would be like the cleanup crew. Here you can see the underwater cleanup crew. Okay, so that was just showing how there were some critters who were all feasting on that whale. And this is specifically about blue whales and how these carcasses can support entire communities of living things found nowhere else on Earth. So you just saw a very small whale and how many things were feeding off of it. But imagine now the largest mammals on the planet. They're the largest animals known to have ever lived on Earth, and these can grow to be 100 feet in length. That one they just showed was 4 to 5 meters. So we're talking maybe 20, 25 feet in length. So this would be 4 to 5 times bigger than that. So when these guys die and sink to the bottom of the seafloor, they can provide then just extensive degrees of nutrients and food that so many other critters need. So Hercules is the sea vessel that they were talking about in comparative size to that whale that was on the floor of the ocean in that video. So this was off the coast of Central California near an undersea volcano, and they were scanning through late at night and found that there were these feeders that were half buried in the sediment, and they saw these things called sea pigs. Lots of sea pigs. They said a whole squadron of sea pigs. And they were watching on these monitors, and then they found octopuses, and they weren't sure why these critters were there. And it turned up that there, underneath all the sediment, there was a carcass of a large whale that had sunk to the floor around that. So they call that whale fall, which is pretty darn cool, I think. All right, so back to today. So today, there we go. So today you're going to be taking a look at your energy period Jamboard. I have posted again the trophic levels video that I filmed out here on the river on Colorado, and I want you to watch that again before you do the energy pyramid Jamboard. You need to be really familiar with the things that I'm talking about in that video and the image that I'm giving you and the imagery and the symbolism I'm giving you of those 10%, of that 10% rule. You have to know that in order to do the energy pyramid. And I'm going to walk you through that in just a second, but you have to make sure that you watch that video again. Today, you then have a quick Edpuzzle. Make sure that it says your name in the upper right. And then you have energy period analysis. And you can see at the bottom here that you have something that says iNaturalist. If you have a phone, I want you to get this free app. If you have a Chromebook, if that is your device, you are going to get the web version of this. This week, I'm going to ask that you get 2 leaves. You need to be thinking about 2 distinct leaves. You need to have these by your next class. So sorry, not Wednesday, the class after that. You need to have these leaves. So just 2 distinct leaves, doesn't matter from where, but please have these ready to go for your class after Wednesday, whether that is Thursday or whether that is Friday. All right, so let's take a look at this energy pyramid Jamboard. So here we can see a feeding pyramid.
So as we already talked about, trophic levels are defined by feeding relationships and changes of energy throughout a system. But not all energy that is consumed by one organism gets transferred to another organism. It's actually only 10%. So to illustrate that, I have a bunch of rocks here. So if we think about a producer is getting this much energy from the sun, this is 100% of the energy from the sun that a producer or a plant takes in. Remember, that's our first trophic level. That's the bottom of the food chain. So from this, only 10% gets transferred to the next trophic level, which is our primary consumers. So this rock is about 10% of that size. So of all of this energy, only 10% of it gets transferred to the primary consumers. So next we have, our very small insects, our herbivores. They get this much energy. So now this is 100% of their energy, but only 10% of this energy gets transferred to the secondary consumers, or the next in the trophic level. So I think that this rock is about 10% of that size. So now our secondary consumers only get 10% of the primary consumer's original energy. So now we have only this. So this is, remember, 10% from the previous trophic level, which was 10% of that trophic level. So every time, only 10% is being transferred. So now if we think about our tertiary or even our apex predators, only 10% of this energy, or something about this size, gets transferred. So think about, is it possible for an ecosystem to have thousands of apex predators? Or can this food chain continue on indefinitely? Is there enough energy to go around? If we started with this much and we ended with this much, so this ends up being 1,000th of what the producers started with. So this explains why we see food pyramids, because eventually there isn't enough energy to go around.
Trophic level. Think about, where would you put your 100% energy? Where is the only place that can go? And remember that there is this amount of energy that all organisms lose as heat. So your body gives off heat and you lose a huge degree of heat, but the rest of it you need for your metabolic processes. So we only transfer a small degree of energy to the next trophic level. The rest is lost to heat. So you need to drag each of these guys, each of these stickies, to where they go within the energy pyramid. So here we can see arrows representing energy going up, and here we can see arrows representing energy lost. So think about that in terms of where each of your arrows or each of your stickies are going to go. When you're done with that, your Edpuzzle should be pretty darn explanatory. And the next component is your energy pyramid analysis. So do this last. So here we're looking at building an energy pyramid. So we want to read about how energy is flowing through a system and how that flow of energy goes. And as you're moving up the energy pyramid, we want to think about how that changes. So remember that this should be the very last thing that we do. So I'm not going to say any more about this. Take your time. Make sure your answers are in complete sentences. And this should be the culminating, the final activity after your Jamboard, after you have gone through the Edpuzzle. And you may need to go back and make corrections to your Jamboard once you get through this. So our ultimate guiding question here is, why is this a pyramid? Why isn't this just a rectangle? Why do you have less predators than you do plants? So that is the question that I would hope that you would be able to answer from this, is why do we have less predators, our top predators, than we do plants? How does energy relate to that? So we want to be thinking about where the most energy is in a food chain, or I'm sorry, a food web, and where the least amount of energy is. So going back here, that is all you have today is your energy pyramid, watching that Trophic Levels video, your Edpuzzle, your energy period analysis, and thinking about your 2 leaves you're going to be choosing. Remember that you will be having a test next week. This will be a longer test. It'll be nearly 50 questions. That will take all of class. So we want to think about taking our time and really learning this material. Make sure you are understanding what's happening to energy as we move from one trophic level to the next. Make sure you can identify those trophic levels. And we need to relate that back to these food webs. You also definitely need to know the difference between a food web and a food chain. And we will be talking more about that. Thank you guys. Have a great day.